Hi guys, this is project number 3 for AMI 3210 Design and Manufacturing, submitted to Dr. Hassan Rashidi. This is a project about design and manufacturing topics, techniques, processes that we like within the subject and things that we have found interesting over the course of this semester. So getting right into it, we'll hop in with injection molding first of all as the most simple process and also the one that I have done essentially the most research on through our first two projects. Injection molding is a process that creates different shapes of plastic by injecting molten plastic into different molds to form them into different complex geometries and shapes. It is really beneficial for allowing the creation of multiple shapes that are unique and can easily be mass produced. You'll find it in most general plastic objects that are very that are scattered around kind of your everyday life, bottle caps, plastic packaging, things like that that can be created in small molds. There are also several different attachments and tools you can use to create different geometries. I like it because it's extremely adaptable and can create a multitude of different products out of plastic very easily. It also has a very cheap manufacturing cost. Some of the capabilities of it are high volume of production. You'll see this through things like bottle caps, once again, actual plastic bottles and such, along with the fact you can make complex parts and molds, things that are threaded and such. Low cost, you can actually control the color just simply because it is molten plastic. And you can also create threaded inserts, as I said before. Some of your limitations are lead time because you do have to create different molds. Design changes are very tough because then you're dealing with having to make a different mold for the product. Size limitations, obviously you can't have too big a mold or else that does create issues. And then environmental impact, you are creating a lot of different molds that sometimes cannot be reused, and thus you're almost stuck with them. But overall, great technique, one that I've become very familiar with after researching the first two products. Topic 2, CNC machining. This is something that I'm the most familiar with, actually, in my general work, especially with Georgia Tech Motorsports. CNC machining is a simple manufacturing process that utilizes computer-controlled machines to mill different metal parts. Applications include automotive industry, medical industry, and electronics industry. I like it because it's easily understood and implemented through different CAM processes. Very easy to create different versions of CAM in order to make your part. And you can create a lot of complex shapes and tools through different tools and axes, whether you're using, a 4, 5-axis mill, being able to use a different one for your own process. Really beneficial, really easy to understand and use, and also very adaptable. You can create extremely complex geometries out of simple metal blocks, which I just find really cool from a practicality standpoint. Some of the capabilities: safety, accuracy, and precision. Once again, they're extremely accurate as long as you set up your cam right. Accelerated production, and they're also automated. It's very easy. You just essentially sit there, and as long as you've done your cam right, you get to watch your part essentially be created by the computer, which is really cool. Limitations, size restrictions. You're working with the size of what can be held within the CNC machine. So dealing with that, making sure that you're not trying to create a super big part in there by CNC machining. Material waste, you are essentially sizing down metal. Anyone who's cleaned a CNC machine before can tell you there is a lot of metal shavings you have to deal with. Human error, setting up your cam wrong. I talked about it a few times there. You can very easily set up your cam wrong and end up ruining an entire part and having to restart a process, which when it's something that's going to take many, many hours to complete, it's a pain. But overall, really, really love CNC machining, especially for creating different metal parts really easily, and especially to accurate size. When you're working with tight tolerances, CNC machining is the way to go in a lot of different cases for a lot of different metals. Topic 3 is IoT. This is something that I researched in class. This is something that I thought was very, very interesting and something that I didn't know about going in. It's essentially Industrial Internet of Things is what IoT stands for. And it's a collection of autonomous devices connected through internet for industrial activities. And you'll find this to use in predictive maintenance scenarios, quality control, safety, and smart factories. And I like it because I think it's a very interesting way, especially as we integrate technology and AI more into our manufacturing methods going forwards in the 21st century. It's a great way to reduce maintenance costs and downtime by utilizing this technology, and also an extremely interesting way of integrating AI into the workspace and into the design and manufacturing space. Um, you can see there in the infographic on the right, kind of your general platform and your general flow of how IIoT works in the workplace. Capabilities, you really can improve efficiency. You get a lot of predictive maintenance benefits out of it, due to being able to track how much machines are actually operating, what their life cycles are, what the mileage is on them. Cost savings can be big. You can very much optimize the workflow in the workspace. Supply chain management, very big as well. Improved quality as well, can really improve the parts. Limitations, privacy concerns, data breaches, same thing that goes with anything with generally implementing technology within the workspace. Maintaining connectivity is also a big thing, maintaining power, and then also skilled and specific labor is needed to both integrate IoT and keep it running on a constant basis in the workspace. Lean manufacturing. This was something I also researched in class that I found was a really interesting model for how we kind of go forwards with improving our engineering processes and getting them to a better spot. It is a system for reducing wasteful excess in the manufacturing process. It eliminates what does not have value in the process. So applications you'll find are generally within factories, within especially the automotive industry. You see this a lot in Japan. Lean manufacturing was actually a concept started by Toyota. And you'll see a lot of different applications just within the factory space. I like it because it's a total optimization of the manufacturing process. There is no waste if you properly kind of integrate lean manufacturing into things. The fat is trimmed away from the manufacturing of a product. So it really kind of becomes the most essential needs and the most essential goals in creating your product. And that keeps everyone more focused. That keeps the workflow extremely focused. And going through kind of the manufacturing and design process, you can stay on track and get less sidetracked through things, as you see in the infographic on the right. Capabilities limitations, you'll find that quality can be improved through it because, once again, everyone's focused on the same product. Reduced waste, not using any excess, not going overboard with things. You're not overbuilding things. You're not wasting both time and material costs. Sustainability, it's big for sustainability because, once again, back to the reduced waste point, you're doing that. And yeah, overall, you're not going to waste more of your product. Limitations, you'll find excess processing, and it's also susceptible to human error. When you're only dealing with what you need and something goes wrong, you don't necessarily have those safeguards in place at times, but you do also have a huge dependence on suppliers to get you excess parts, any spares that you need, or anything of that sort. So you sometimes do deal with some dependence and some issues alongside that. Overall, though, very, very interesting process. It's something that I really like, and something that in my own workflows I've definitely tried to see what exactly I can cut in terms of excess. Last topic here, tailor welded blanks. This was something that I found in the textbook that I found really interesting. It's a sheet metal forming operation with a singular blank that has uniform thickness, and you're able to shape it into the shapes you need. Also, you can go ahead and weld different pieces of sheet metal of different thicknesses and form them together. Applications, the biggest one is the automotive industry. This is an industry that I find really interesting and that I would like to go into after college. So that's why I have so much interest in it. I thought it was a really interesting way to create much lighter parts, especially dealing with my side of things, which is on the motorsport side of automotive engineering. You look at lightness as kind of your gold standard and what you want in an automobile. So being able to use this process to effectively reduce the weight of cars is a very, very interesting topic that kind of came about throughout the automotive kind of design revolution of kind of that late 20th century aspect, when things became much more restrictive, especially due to fuel economy and fuel mileage. I like it because it's able to create large shapes with general consistency, and yeah, it allows for much lighter automobiles, and I find that a really interesting aspect of them. Capabilities, weight reduction, that's the biggest thing. Improved crash worthiness, that's obviously a huge standard in the automotive industry, reduce manufacturing cost, always a benefit to reduce your manufacturing cost. And then improve dimensional accuracy. Being able to take a large scale blank and make it extremely accurate is something that is very, very interesting. Limitations for formability, same thing. You're dealing with a very big piece. Same thing as you'll find with a lot of stuff. Size limits and material limits are also issues, and then weld seams are also very susceptible to kind of differences and some manufacturing tolerance issues. They're the resources I've used for this, and as always, the disclaimer at the bottom that this is for educational purposes only.